Hello, Algebra 2 students. I'm going to go through with you today the graphing of logarithmic functions. So if we'll just review really quickly here, lesson 17 day 1 was the graphing of exponential functions. All right, so we're going to take a look at pretty much doing the same kind of process, same idea, with the graphing of logarithmic functions. All right, so our first example that we are going to be doing is for f of x equals log base 3 of x. So we want to do what we've done before, which is want to make ourselves a nice XY table here. All right, and we want to make a nice graph. So let's get the line tool here and give ourselves a nice set of X and Y axes. And with our X and Y axes, of course, we want to make sure is that we put arrows. All right, we'll put arrows here. And then we're going to get started. Well, actually, we can do some scaling. Probably goes out to 5 on each axis. All right, so I'm going to go a little bit left there, and then 1, 2, 3, 4. All right, down to -5 there. All right, so let's go ahead and see what Desmos gives us when we put this in for a graph. Okay, so we got, you're going to hit the keyboard down here, and we're going to type in y equals, and we're going to go to functions, and what we want to do is we want to choose this one right here, okay, where it says log base a. So this is going to allow us to type in any base that we want. So we want a base of 3, and then this is going to be our x. All right, and we're going to close parentheses. So, anyway, let's take a look at this graph, okay? Right now it appears, okay, if we kind of like zoom out a little bit, it appears that the graph comes like perfectly vertical, right? Perfectly straight down and rides along the y-axis. But in actuality, okay, if we were to zoom in as opposed to zoom out, really look and see what's going on here. So yeah, it does look like it's getting really close, but what happens if we keep zooming out and we just kind of keep looking? See, it keeps getting closer and closer, but is it actually ever going to reach? So every time I think it gets really close and it's reaching, if I zoom out, well, now look, doesn't appear like it's going to reach anymore, okay? So it's all, a matter of how zoomed out or zoomed in you're in. But anyways, let's take a look at the table. Remember I told you that you can hit the little gear shift and a little table, right? This gives you a table of values. Now, Desmos automatically goes with -2, -1, 0, 1, and 2. But for this logarithmic graph, does this work out nicely? I mean, if you remember a statement that I said about logarithms, all right, you can only take the logarithm of a positive value. That would make sense as to why these x values of -2, -1, and 0 don't even have defined y values, right? So what we need to do is we need to come up with some other x's, okay? So let's think this through. If this is the equation of y equals log base 3 of x, and we know to evaluate a logarithm is to ask ourselves what power should we raise the base of the logarithm to in order to get what we're taking the logarithm of. Well, this right here, if this was a 3, if we do log base 3 of 3, ta-da, look how nice that is. That's a y value of 1. And if we have log base 3 of 9, right, that's also going to be really nice, right? Because 3 raises to the power of 2 to give you 9. So log base 3 of 9 is 2. So there you go, right? So now we have a couple of nice points. Well, how about some more x values for points that are going to be right in here, this portion of the graph where it goes below the x-axis, right? What's going to be in there? Because we know the graph exists, we can see it, but we don't want to just take only these points and plot them and not realize how the graph connects. So let's think really carefully again about how this is log base 3, and what, when we raise 3 to a power, what could we get as the value? Well, what happens with a negative power, right? What if I raise 3 to a power of -1? I would get 1/3. So if I do log base 3 of 1/3, ta-da, there's the -1 value. And likewise, how about if we do 1/9? Right, so what do we get for log base 3 of 1/9? We get -2. Why? Because that base of the logarithm, that's 3, would get raised to the power of -2 to give you 1/9. So now I can see some more nice points in here that I can, put in my XY table and plot. So let's do that, okay? Let's come back over here, and we'll put in 1/9, which is -2. We'll put in 1/3, which is -1. 1, which is 0. 3, which is 1. 9, which is 2. Okay, so anyways, let's plot those points. Okay, so 9, 2 is all the way over there. And then we got 3, 1, we got 1, 0, we got 1/3 -1, we got 1/9 -2. So anyway, take this x-intercept and connect those points going to the right. Now, make sure, I mean, I know I'm kind of off my screen here, but think about it, right? I could absolutely have larger x values, and those y values would keep getting larger. So this graph is going to forever go to the right and go up as it's going to the right. Now, how about connecting these points in here? So be careful. We don't want to make it look like the graph is going to intersect the y-axis. It's not. It's going to get infinitely close to it, but it's not going to intersect it. Now, that's going to be the same idea as what we already saw with the exponential function, okay, from lesson 17, day 1, which is that there's going to be an asymptote, right? That's that line that we think to draw with the dot. We draw it with a dotted line because it's not really part of the graph. It just helps us make the graph. And the graph gets infinitely close to it but doesn't actually reach it. So let's draw that in here as well. I'll choose the purple. That'll stand out nicely. All right, that's going to be right here. We're going to write down vertical asymptote. Okay, and we're going to write down the equation of x equals 0. Okay, so the graph will get infinitely close to the y-axis but never actually reach it because it's going to be an asymptote. So anyway, I'm going to now do a couple other nice things with you with this graph that we did with the other one, and that is we're going to state domain and range. That's one thing that we're going to do, okay? So remember, domain is all the x's, range is all the y's, and this time it's the range that's going to be all real numbers, okay? So if we think about the range, the y values, the graph's going to forever go down, right? And then over here, the graph's going to be forever going up. So the range is going to be all real numbers, okay? And that's that lovely R symbol right there, okay? If we want to do it in interval notation, that would go from negative infinity to infinity, just like that, okay? And now it's the domain, though, that's not all real numbers. So the graph forever goes to the right, but it doesn't forever go to the left. See, it only goes as far left as this vertical asymptote, right, as the y-axis. So our x values are actually going to be greater than 0. Okay, now in interval notation, that would be 0, comma, infinity. All right. So anyway, oh, and a couple more things that we want to put down. So if there's an intercept for your graph, you want to state its coordinate and name what it is. So this is an x-intercept, and that's going to be the point 1, comma 0. And then also, is this graph increasing or decreasing? So as I told you with the exponential function graph, always read your graph from left to right, the way that you would read any kind of sentence if you open up a book. And what do we see the graph doing? We see it increasing, all right? So this would be what we call logarithmic growth. Okay, so it's a logarithmic graph and it's growing, right? It's increasing, so this would be logarithmic growth. All right, so anyway, that's kind of like the gist of what you're gonna do for your homework problems. But now let me just show you a couple other things in Desmos, just to make sure that you feel comfortable putting everything in. So how about if you have a natural logarithm, right? We certainly have done natural logarithms. So we are gonna just type in y equals, and all you gotta do to get a natural log is just hit functions, and you probably saw it already when I was quickly doing log base A, just right here. So you just do natural log x. And I don't know if you can see here, but this graph looks extremely similar to the graph that we just did for y equals log base 3 of x, okay? Reason being is because it's it's a graph with an extremely similar base, right? This is a base 3, and natural log is a base of e being about 2.718. So you wind up getting essentially the same looking graph, okay? So, different bases will give you maybe a slightly steeper or flatter graph, but as long as the base of your logarithm is greater than 1, it's going to be logarithmic growth. So what if your base is less than 1? Okay, your base can never be negative, but what if your base is less than 1? So what if I type in y equals, okay, and I go back to log base A, I type in a base, let's say, of instead of 3, how about 1/3? Okay, but I reciprocate that. Now, unfortunately, I haven't figured out how to put in a base of 1/3 as a fraction, so we're just going to type it in as a decimal, 0.333333, and it's about 1/3, and so anyways, of x, and there you have it, right? See, there's logarithmic decay, right? As we read the graph from left to right, it's decreasing, right? So this would be a logarithmic decay graph. Anyway, you do the same thing that you did before. You hit the gear shift, you pull up a table of values, okay? You plot your points to replicate this on your graph paper, and then you just answer the same kind of domain range questions, what's your asymptote, et cetera, et cetera. Okay? So I hope you have an okay time with this, and we'll talk more about it on Monday. Have a nice weekend. Bye.